Momentum and impulse. In this section, there are many different formulas that we use, and here are a few. The first one being momentum, the second one being impulse, the third one being your F net, and the last one being the most common one. An elastic collision is when there is no deforming of the object, meaning no joining. An inelastic collision is when there is deforming of the object, meaning the objects join. When doing impulse and momentum, you always have to take direction. And if you need to prove if something is inelastic or elastic, you need to use kinetic energy before and kinetic energy after. If there's a change, it's inelastic. If it is equal, it's elastic. There are many different scenarios that I've put together for this video, so you get an idea of all of them. This is before and this is after. So I want you to picture these as trolleys or carts or something movable. So this one's 2 kgs and velocity is 10, 0.5 kgs, and this is 5. This is before, and they're both moving to the right. This is after. The velocity is 4, the velocity is unknown. This is still moving to the right. You don't know the velocity. This is the equation you use. You substitute the mass, meaning the 2, then the 10, then the 0.5, and the 5, then the 2, the 4, the 0.5, and the velocity is unknown. You solve for the velocity unknown, and you should get 29 meters per second squared to the right. Don't forget to take your direction, and in this case we took right as positive. The next scenario is here. You have this one going to the right, this one going to the left. Here your velocity is unknown, and here it stops. If something stops, it means 0. Again, we've taken right as positive. This is before, and this is after. You use this formula, you substitute exactly like how we did in the previous scenario. However, this velocity is unknown. You end up with your answer as 8,75 to the right. This is the next scenario. This is still moving to the right, and this is still moving to the left. However, in the after, they are both moving as one. They are joined. We're still taking right as positive. We use this formula. However, we take this out and you make one mass. So your mass is 2 plus 0,5. So you'll put 2,5 and you put your velocity as unknown. And you're solving for one velocity since they are combined. Thus, your answer should be 7 meters per second to the right. This is another scenario. So this arrow, imagine, is a person and this is a skateboard. So the person's mass they've given, the skateboard mass they've given, and the velocity is 0. At the end, the velocity is 2 and the velocity is unknown. We're taking right as positive, and this is the same formula. So because they're combined at the beginning, you have the mass as 55 kgs and 0. 55 times 0 is 0, so you'll have 0 on the side. And then you just solve for the skateboard. Now, the answer is negative, and you took right as positive. Thus, if the answer comes out to negative, it will be left. This is the last scenario. So imagine that this is a ball. They give you the mass, the velocity initial, the velocity final, and they tell you to calculate the impulse. This is the impulse formula. Now you have the mass, you have the velocity final, velocity initial, and now you just solve. However, you end up with a negative figure, and you took right as positive. So if you took right as positive and you have a negative answer, that means that the ball is actually moving to the left.